distillation with Robert Smith. I'm going to go over the system overview of the distillation column itself, and then the operation of what we do when we run it, just as far as turning it on. And then go through we did water-only trials for the first week, and then we did a mixture of water and ethanol after that. And then the conclusions and what we're working on for future weeks. Here's a diagram of our distillation column. What we do is when we put water in, or water and ethanol, we add everything to the reboiler, and that's where the heat is put it in. And then as it heats up, the materials vaporize and start going up these trays, all the way up to the very top. There's a condenser, which is up here, and that's where the heat's taken out and the fluids condense back down. And notice the way these are numbered, where 12 being the lowest, the closest to the reboiler. So you see on all the graphs, that's going to be the hottest, the one that heat up first, and have the highest composition of. Well, we'll get to that. Here's a picture of the computer screen on how we control the distillation column. We can control the reflux percent, how much of the percent of the vapor that's condensed that we collect, the wattage going to the reboiler, and we can also watch or see continuous feedback on what's actually happening within the distillation column. On the 100% water trials, we're just trying to get an idea of how the system operated and how it responds to inputs, and it allows us to get a known temperature, another point of known temperature to calculate the temperature probes. Here's what our data looked like when we collected for the first set of water trials. We also were, you'll notice as it starts off, the time 0 minutes, it's already heated up. We didn't realize that you had to put a certain login name, otherwise it cuts off after 15 minutes. But you can still see all the temperature ranges at 100 degrees. They vary somewhere all the way up to 105, somewhere a little bit below 100, and they should all be right at 100 degrees Celsius for the boiling point of water. And same for room temperature at the beginning, so there's a lot of variance. So we took these and just plotted, just using 2 points, and calibrate the temperature probes. And this is what it looked like after with the corrected temperatures on there. So they all rise to right at around 100 degrees, and then the room temperature I think was 27. We could also, based on the power we put into the reboiler, we had the temperature of the cooling water as it's being supplied, and the cooling water when returned from the condenser. We could use that temperature difference, the power, and then specific heat of water, and then the flow rate to determine the amount of energy absorbed by the condenser. There's the equation we used. And it helps us come with just a early rough energy balance for the column, what we put in and what we got out. We know we put 2,000 watts in, and the condenser absorbed about 1,000 watts. So there's about another 1,000 watts being lost just from the reboiler and the column itself. For the water methanol trial, we mixed 1 part methanol for 10 parts water, which translates to 13 kilograms of water for 1.03 kilograms of methanol, or 0.72 kilomoles of water, and 0.057 kilomoles of methanol. Here's for 300 minutes our data. These are just the temperatures. These are the correct temperatures. And bear in mind from the first diagram, tray 12 would be the closest to the reboiler, and as you go up to tray 1, that's the closest to the condenser. So you can see the trays 1, 2, and 3. As the experiment went on, they were right at about 65, which is right around the boiling point of pure methanol, and then the other trays were up closer to 100. Was trending closer to 100 for water. And these would be down in the reboiler and the trays closest to it. And you can also see from the 2 water trials we did beforehand, that as we started heating up, each tray still had a little bit of water in it from the trials before. So as vapor was going up and condensing down, the trays actually, they peaked up higher for, I guess they were pure water. And as the concentration went closer to pure methanol, the temperatures trended flipped down to the methanol's boiling point. And these dips right here were where the power cut off on the reboiler, so couldn't really control that. Here, I zoomed in on that first peak, and then I also added this beige line, which is our reflux percentage. You see it has, when we started off at 100%, we're not collecting any distillate. When we changed it to 90%, and that's on the right-hand side, the axis for the reflux. When we changed it to 90%, means 10% of the oil condenses we collect. And as we drop down to 70%, you can see that the temperatures start to rise in these trays. So the purity of the methanol was decreasing until we after around 160 minutes, we went back up to 90%. We started to trend back down, becoming more and more pure. Current projects and what we're working on for next week is we're going to rework the distillation collection. Right now we have the jars kind of our receiving calls. We have a jar right here that the distillate comes down and gets collected in. And when it gets to a certain level, this pump kicks on and it sucks the methanol at the bottom, or the distillate, into here and pumps it out into this beaker. And we find out that since this container is higher than this, that it would just siphon, instead of just the set amount it was supposed to take out once the pump cut off, it would slip past the pump and just siphon everything out of the container. So we're gonna try to rework that and just have them all level and change this container, which is about this big around, to maybe a beaker, so it'd be a smaller amount each time. And then we also want to work on the reboiler where it keeps cutting off, see if we can eliminate that. And then just further data analysis all around, just more things we can calculate and try to narrow down on the other, on the heat loss for the energy balance. Trying to determine exactly where and how much we're losing for the other heat. Any questions?
Well, you know what we do when the presentation is over? Questions?